Up we have Dilip Joseph, the first talk in our three-talk series of companies outside of UCB, actually outside of the AMP lab, that are company-like things, because Tim will be talking about Mobile Millennium, which is a UCB project. But this is, Dilip is an engineer who at Conviva, who was recently graduated from Berkeley with his PhD out of the Rad Lab, the predecessor to the AMP Lab, had worked with Jan, and is now still working with Jan at Conviva. He will tell us about Conviva's use of Spark.
Great. Thanks, Andy. As Andy said, my name is Dilip. I was a student at Berkeley, not very recently, about 3 years ago, and now I work at Conviva as a staff engineer, and we have been using Spark for more than a year now, and it's been very helpful for us. So I'm going to describe a little bit about how we use Spark at Conviva. But before I do that, I wanted to give a brief introduction to what Conviva does. Conviva is a startup in the online video space. We are located in San Mateo. What we do is we help monitor and optimize online content for a variety of online content providers. For example, if you go to hbogo.com today and try to watch the latest episode of True Blood, so there is Conviva technology sitting in the background, monitoring your experience and making it better, optimizing your video experience. By optimizing your video experience, I mean reducing buffering. I mean, nobody likes to be interrupted while watching True Blood, right? So you don't want to be interrupted. You want the video to start up as soon as possible, and you also want to get the highest quality possible. Everybody wants to watch HD quality video. So we help content providers like HBO, ABC with video on demand content. We help sports sites like ESPN with live streaming content. So what happens if you don't use Conviva? So we don't really have to go very far for an example for that. And if you have logged into Piazza, you probably saw this post. And that's what happens if you don't use Conviva and you piss off users. Well, fortunately, the users here are very mild. I mean, crap is the worst word out in this chain. But that's not usually the case. You're watching an online soccer game, and your video buffers when somebody's about to hit a goal. You're not happy, and you're going to complain on social media. You're going to complain on Twitter, where Ben's Mesos cluster is going to pick it up immediately and process it and bring it out for the world to see. And your company is not happy. So this is the kind of problems Conviva is trying to avoid. We're helping video content providers help get the best possible quality, video quality for their viewers. So we serve a lot of video content providers around the world. Overall, in a typical day, we see around 65 million video streams. Just to put that into perspective, YouTube is about 10 times more, about half a billion video streams a day. Of course, that's not an apples-to-apples comparison because YouTube is a content provider. It hosts the content, and it delivers the video bytes themselves. We are more like a control plane for online video, but I just wanted to put the YouTube number out there just to give a perspective of what 65 million streams a day is like. And as I mentioned, we monitor the online video. We collect a whole bunch of very, very fine-grained statistics about your video watching experience. And we do that for 65 million streams a day. And that works out to a lot of data. And before I go into how we use Spark to process the data, I want to give a high-level overview of how we collect the data and a picture of our basic architecture. So everything starts off at the video player. The video player could be your laptop. You go to hbo.com and watch True Blood. That's your video player. It could be your iPad. It could be your Xbox. It could be your phone. It could be any video player. So it all starts with the video player, and there is a little bit of Conviva code which is sitting inside your video player, monitoring your video experience, and periodically, a couple of times a minute, it sends back these fine-grained video statistics to the Conviva backend. Once it reaches the Conviva backend, we split the data into two. Rather, we make two copies. The first copy goes into the live data processing stack. Now, this is a custom-built processing stack which processes all the video analytics data coming in near real time. And by near real time, I mean with the latency of about 2 to 3 seconds. It processes the data and makes it available in our monitoring dashboard, which we call Pulse. Now, our customers, which are content providers like HBO and ESPN, can log into this monitoring dashboard and see in near real time how their video is going. Like, is one video suddenly become popular? Or are viewers in, let's say, North America are having problems watching my video? If yes, they can drill down deep and try to find out what the problem. Maybe there's a problem with the CDN in that region. In that case, they know that they can call up their CDN provider and say, something's wrong with my video, fix it. So we provide real-time insights into monitoring a video and also fixing the problems. A copy of the data goes into Hadoop for historical data processing. So all this data goes into Hadoop. From there, we do periodic jobs every 5 minutes, every 1 hour, every day, etc., to process this raw data and make available a bunch of statistics, again, online video statistics. So these MapReduce jobs run periodically, and this data also goes into the monitoring dashboard from which our customers can drill down into historical data. On top of that, we also produce a variety of offline reports. Offline reports are not generic statistics, but very highly specific reports about video. And to do this, we use Hive and Spark. So typically, we run a bunch of Hive and Spark queries, and the results of these are encapsulated into like PDFs or Excel reports, and these are sent to our customer. We also use Hive and Spark to do ad hoc analysis. The example I gave earlier, it's a customer calls up and says, oh, something's wrong with my video, can you look into it? So we need to do ad hoc queries in Hive or Spark to identify the problem and try to figure out how to fix it. So we also use Hive and Spark for that. In this talk, I'm going to be talking about how we use Hive and Spark only for reporting. So let's look at our reporting workload. We run a variety of reports, but most of our queries fall in this very simple structure. We do a simple group by query. So this is an example of possibly the simplest group by query, where you have you want to find out the number of times a person watched a particular video. It's very simple. Obviously, we have many, many more metrics than simple counts, and we also have many, many more group bys, and we do joins and all those kind of things. But the high-level structure is very similar. We do a group by on a particular field and calculate the different metrics for those groups. Let's see how we can write this group by in Spark. Now, since most of you did the exercise yesterday, I don't have to explain what the Spark code does. But at a high level, we are reading the summaries about the video analytics. We read that from HDFS. From that, we extract out the fields we care about. Then we filter the sessions. Basically, we get the sessions for the day of interest and the customer of interest. And then we call cache so that Spark caches it in memory. And then we do a simple group by where you map the group name to 1 and then keep adding up. It's very, very simple Spark code. But of course, this is definitely not as concise as the SQL-like query we saw earlier. So why in the world would we want to do this? Well, the reason is very simple. This worked about 30 times faster than Hive. So we used to have a report called the Conviva Weekly Geo Report. It's basically a very comprehensive analysis of how different CDNs like Akamai, Level 3, and other CDNs perform in different parts of the world. It's a very big report involving tens of group bys and a whole bunch of different tables. So this report for a week used to take about 24 hours to run when we were using Hive. But then, and that is clearly not sustainable. So every Monday, our Hadoop cluster is completely unavailable for anybody to do any useful work because it's crunching this report, and people were unhappy. So we switched to Spark, and then that same report now just takes 45 minutes. So it's about 30x speed up. And that's the only reason, that's the main reason we are using Spark. How big is the data slice? Exactly. So it's not a lot of data. It's not a small amount of data either. So it's about, for the weekly data for the Conviva Geo report was about 150 gigabytes compressed, and it's about 3-to-1 compression ratio. So it's about half a terabyte, 450 gigabytes, like half a terabyte. And it's stored in HDFS as sequence files, and we use a custom binary serialization format to represent the data within the files. So let's look at why Spark is faster. The main reason Spark is faster. Sorry? Oh, sorry, question.
Did you run the same thing with Shark?
No, the question was, did we run the same thing with Shark? The reason is no, because we did this about a year and a half ago, and Shark was not available then. So that's why we had to write Scala code for. I'll come back to Shark a little later. So the main reason why Spark worked much faster for us was it avoids reading the data from disk multiple times, unlike Hive. So when we ran the Hive query, we have a bunch of group bys, say group by country, group by state, video, and tens of others. So every time we run the Hive query, it has to do the same thing over and over again. Read from HDFS, decompress the data, deserialize it, then do the actual computation. Then again, the same thing. Read the same thing again, decompress, deserialize. However, if you're doing it in Spark, we read from HDFS and do the decompression and this deserialization, and then cache it in memory. It does it once, and all the subsequent group bys just read it from memory, and it's super fast. On top of that, we also get some other advantages. Like we're running tens of Hive queries, and each Hive query results in maybe 5 or 6 MapReduce jobs. There is a fixed overhead with each of these, and if you're running like lots of queries, they do add up. And fortunately, Spark does not have most of these overheads. The Spark queries, even if you're running a single Spark query and not utilizing any of the disk caching benefits, Spark is still faster than Hive. So when you're running like tens of Hive queries and MapReduce jobs, the overheads do add up. The other advantage is that when we're running multiple Hive queries and MapReduce jobs, by using Spark, we're avoiding the data, the intermediate data from getting flushed to disk. That also gives us some benefit. When we're using Spark, we also only cache the columns of interest in memory, so that saves us memory as well as increases the speed of processing. Typically, our data contains like about 100 fields. For any one report, we normally require only like 10 or 15 fields. So there's no point reading all the fields again and again. So we cache only the columns of interest in memory. Question? Sure. So the first question was how many Spark queries we run every day. And the answer to that is we probably run like the question is, I'm not sure what exactly a Spark query is. We have a job which runs a whole bunch of Spark jobs, which that could be counted as multiple queries or multiple Hive queries. But at a high level, reports, we run about 50 reports every day morning, and it depends on the day. If it's the end of the quarter, everybody wants a report, we run like a few hundred. But if it's like on a Friday night, probably nothing's running. So it's on demand. It's depending on like if you're onboarding a customer, we run more. But typically it's about like 50 on a normal day and a few hundred on like a hectic day. But again, each Spark job does a lot of passes over the data. Like one Spark job could go over the data like 100 times. So, and the second question was what is the size of the cluster? So we've been using just for the reporting infrastructure for Spark, we've been using just 4 nodes, and each of those nodes have got 16 cores and 96 gigs of RAM. We are using Spark for some other purposes, so we have like 10 more nodes which we are going to use for Spark, and each of them has about 200 gigs of RAM. Okay, so now the question is, why didn't we use some other system, and why did we go with Spark? Well, we already talked about Hive. The main reason we started using Spark was because Hive was slow for us. What about MySQL? Half a terabyte is big, but it's not impossible for MySQL to handle. But half a terabyte per week is not going to work out for us, and we tried. It doesn't work. So no MySQL or a regular database like that. What about Oracle or SAP or products like that? Well, they probably work, but for a startup like us, they sounded like expensive, so we didn't explore that option much. What about column-oriented databases or other data warehousing solutions? Again, I must admit that we didn't really evaluate them because, well, Spark just worked for us. I mean, we had a query which was taking 24 hours. It took 45 minutes after Spark, and we were happy, and we went on to do other things. So basically, it just worked for us. It was a great fit for our computation model, which is basically load a piece of data into memory and do a lot of computation on top of it. So it worked. It fit very well with what we are doing. And it was open source, it was flexible to do other kinds of computation, it was scalable. So for all these reasons, and it just worked, we just chose Spark. So today, again, somebody asked how many reports or how many Spark queries we run every day. So 30% of the reports we run every day use Spark. And these reports are run as follows. So our sales team or our customer service team logs into a web-based portal, and they configure a report like, say, you choose the customer, you choose the date range, and you configure a bunch of other parameters, and then hit run. It asynchronously runs the reports, 30% of the reports on Spark, and the rest on Hive, and then it emails them the PDF or the Excel file. So today, 30% or probably more. Now, this number was like about 2 months old. Probably more runs on Spark every day now. We are working on more projects that use Spark. One of them you already heard about, which TD talked about, was Streaming Spark. TD was interning at Conviva this summer, and he was trying to unify our live processing stack, which I talked about very early on, and our periodic Hadoop MapReduce jobs. So it's a big pain to have two different processing stacks to compute the same data, one for live and one for historical data. You got to fix bugs in both. You got to make sure that the metrics match in both. So it's a big ongoing maintenance problem to have two stacks. And what TD with Streaming Spark showed that it is possible to use our existing MapReduce code, which is run periodically every 5 minutes, and make it run every 2 seconds to get the live analytics we want. As part of that, TD did all this work. He also got Spark to use existing Hadoop MapReduce jobs. So you basically take an existing Hadoop MapReduce job, you have some wrapper code, you put it together, and it runs on top of Spark. So the current name for it is Shadoop, and we are working towards open sourcing it. So now, problems with Spark, yes. So you've been watching presentations about Spark, like for the last 2 days. So I'm sure the biggest problem is like obvious to you, right? No? Well, biggest problem, there's no logo. Look how bad my slide looks. And I mean, you have such a nice elephant bee out here, and Spark is like Helvetica text or something. It's just a big problem. So that's one problem. Well, since there's no logo, I have to do like bad things like this to make my slides pretty. So please have a logo so I don't have to do this. So let's look at another problem, a much smaller problem, of course. That the query is like, we already saw this query. The Hive query is much more succinct and much easier to understand than the Spark query, because you have to write this stuff in Scala, and that is a problem. Oh, sorry, logo problem again, but ignore that. So there was a learning curve associated with Scala. When we first started using Spark about 1.5 years ago, we didn't know any Scala. So there was a learning curve associated with Scala. But using Scala, it was much easier to construct big queries. Some of our Hive queries are like this long. It goes into like 10 screens. Of course, we automatically generate them, but it's very hard to construct very complex Hive queries. But if you're using Scala, we just open up Eclipse, and using the Scala plugin, we just get the type safety and the code completion. It's much easier to write queries in Scala. And of course, if you've written Hive queries where you have like if this, else that, if this, else that, and like 10 levels of that, you know what will go wrong if you forget like one parenthesis or something. Scala avoids those kind of problems just because it's compiled and it's statically typed. And of course, now this was 1.5 years ago. Now, as you heard, if you don't want to write Scala, you don't have to. You can either use Shark, or you can just use the Java or Python API. So this is no longer even applicable. Some additional hiccups. As I mentioned, we've been using Spark for about a year and a half now, and we've always been on the bleeding edge, which means we like check out trunk or some other branch and then try to install it, and used to keep getting like dependencies wrong, but that's not a problem anymore with the 0.5 release. It's much easier to install it. And you also saw how easy it is to install from the AMI. You basically don't have to do any work. So this, again, I'm talking about problems we had. These are not necessarily problems we have, but I just wanted to share our experiences while we went along this path. The other thing we had was some maintenance tools and some debugging tools were lacking. For example, some of our disk drives used to get filled with like log data or shuffle data. Again, those things are improving. These are all just minor problems, and they are improving as we have more and more people using it and more and more tools are getting developed. Question?
How do you manage workflows?
How do we manage?
Job dependency workflows. Do you have that at all?
Are you talking?
Like
The question was, how do we manage work dependency workflows, similar to like how Uzi does? We don't use Spark to do that. Spark is just a component of that. We have other workflow systems, which we have our own internal system to track workflows. For example, if I want to compute a report for like yesterday or the past hour, I need to make sure that the data for that hour is available and summarized. So we have like an external, not external, we have a separate internal tool to do that. And we just fire off the Spark jobs when the data is available. So that's all I had. I just want to conclude by saying that Spark has been working great at Conviva for more than a year now. It's very easy to use, and it's made a lot of our lives easier. So I would highly recommend trying it out, and you'd be amazed at how fast things can go if data is in memory, and it's very useful. So that's all I have, and of course, my thank you slide is, as usual, the we are hiring slide, and we are hiring, so thank you.
Questions?
How do you get your client installed on the user machine?
Oh, okay. The question was, how do we get the Conviva code installed on the user machines? So when we integrate with our customer, so when we integrate with HBO or any customer, there is an explicit integration step. So you as a user won't install anything. It's integrated into our customer's player. So if you go to hbo.com, it's already integrated. You don't have to do anything. So there is an explicit integration step when we get a particular media company as a customer.
I thought you were talking about the laptops, right? Like on iPads.
Oh, the same story with everything. We are integrated directly into the video player. So if you download the video player app, if it's our customer, we are already in there. Yeah, question?
How do you persuade your customers they're going to work, the method is going to work?
Sorry.
How did you persuade your customers your method is going to work?
Is your question how we persuaded our customers which method is going to work? Am I talking about Spark or in general?
The whole method using Spark and extracting analytics and doing perhaps machine learning and find out the problem and so on.
So the question is, how do we convince our customers that the whole approach of collecting the data and analyzing it, and I don't think Spark matters here because our customers typically don't care what we use. I mean, so we can use Hadoop, we could like do it by hand, they don't care. But we use Spark, of course, and Hive in some cases. But how do we collect? We just we just show them the value of the data. I mean, we show them real problems, which they didn't know. When we look at the data, we find things they didn't know themselves. And if you can show somebody, somebody who's doing this full time, we can show them things they didn't know, and they think, this is the problem. It's so obvious once you tell them that. Once we give them a few experiences like that, it becomes easier.
But you didn't have the data to start with.
Oh, we didn't have the data to start with? Oh, we have a stellar sales team. Any more questions?
So I think Spark is you use it and you will encounter some bugs during the real production. And when such a situation happens, what are you doing, and how easy to work around such kind of things?
Sure. So the question was about like what do we do when we encounter Spark bugs? So we haven't encountered a lot of Spark bugs. I can't think of anything we encountered. Okay, one reason could be our use case is not extremely complicated. We are doing something very basic, and it's a very basic thing. It works very well, and we have just started looking at things like broadcast variables and all those kind of things. We didn't do any. Mate talked about a lot of advanced features. We didn't have to do any of that to get the speed up we got. I'm sure if we do more of it, we'll get more speed up, but we're satisfied for now. We'll obviously do those things later, and we may encounter more bugs. But for the stuff we have been doing, we haven't really encountered any bugs. And if we're confused about something to do, we just email Mate or the team and mailing list. So that's basically how we do it. But we haven't encountered anything which was a blocker.
How is Shark working out for you guys?
The question is, how is Shark working out for us? We just installed it. We just installed Shark like a couple of months ago. Renaud and his other members of the team came to Conviva. We sat down, we installed it, and it works great. The only reason we're not using Shark more is because all of our jobs are like, it's on a web portal. People just click on it. It all works fine right now. For new stuff, we will use Shark. For now, the thing we already coded up in Scala, we don't want to change because it works and we have a lot of other things to do. So. Yes.
The reports run on how big of a time span, like 1 month, 1 week, or?
So most of the reports run on daily data.
Will you repeat the question?
Oh, so the question was, what are the time span on which reports run? Is it 1 week, 1 day, or the size of the data? So most of our reports run on, the bulk of our reports run on daily data. So it's 150 by 7. Or We do have reports which run on weekly data, so it's 150, and it's growing very rapidly. And we do also have monthly reports, which do run. But the monthly reports are tricky to get into Spark because we don't have enough memory to put all of them.
Exactly. So you said because you have 4 nodes each with 96 gigs or
Mhm.
something, right?
Yeah.
Your daily use case fits very fine in the memory model.
Yes, daily and the weekly also sometimes, mostly.
For stuff like for us at my place, it's like pretty big tables and they have like a pretty big span for the reports.
Mhm.
And we are using I right now and thinking of moving to Sharp.
Mhm.
But the same problem I think I'm running into, like we have like maybe 200-300 nodes, but still if you multiply by the memory, it's not going to fit the whole thing in memory.
Sure.
So I don't want to run into caching problems. So what do you suggest right now?
So well, if somebody asks you for the question was, what do you do if the data does not fit in memory? If somebody wants to somebody wants to run a report with for a very large time span, the first thing you do is you put a sad face and ask them, do you really want that report? If they really do, you like ask the CEO for more money to get more nodes. Even if that doesn't work out, we do like the standard tricks, like we load only the fields which we really care about. Like, as I mentioned, our data has got like 100 fields. Can we run the report in batches? Can I load just one field at a time, run the report, and then somehow manually combine it? And sometimes it's okay. If I want a month-long report, the people are more than happy with getting 4 weekly reports. So we do, we try to change the request so that we can handle it, or we try to compress, or we use better serialization. Right now, as I mentioned, we're not using any of the more advanced features. We're using like standard Java serialization. I know it's very inefficient, and it's not. It's one easy way to make it fit is use cryo or something else.
Last question.
Just on a comment on this, have you considered using streaming with bounded memory usage to get over this limitation of fitting everything into memory?
Streaming with bounded memory usage is featured as the bounded memory cache of Spark.
I mean, I'm just thinking that when you're processing in a streaming manner, you can operate, or generally you want to operate with bounded memory.
Mm-hmm.
So even though your entire data set might be very large, if you stream that data set and break it into small batches as you're processing it, you don't need as much memory, right?
So I'm not sure if that fits into the, are you talking about Spark jobs? I'm not sure if that fits into the Spark model. But for our regular streaming thing, that's exactly what we do. We process in batches. For our custom streaming thing, we process in batches. But for the Spark thing, right now, we're just, we are relying on Spark to load the data in memory and do the cache management for us. We are not doing anything specific. We're just letting Shark do its own, either using its bounded memory cache or whatever other caching policy.
I can take it offline.
Okay.
Thanks.
Thanks again, Dilip.
Thank you.